Welcome back to my channel. I'll take a couple of sessions on some of the easy to medium lead code problems. Please like and subscribe and press the bell icon to get notified of the upcoming tutorials. Today we are going to understand how you can find an element in a rotated and a sorted array. So we know that an element can be found in a sorted array in big O log n time using binary search. So if an array is sorted, the complexity to find an element in that is big O of log n, and this is done using the binary search. What if the array is sorted? What if the array is rotated? So there are two approaches to solve this problem. Let's start one by one. I'll take an example. Let's say first I'll explain you the meaning of what I mean by a rotated array. Let's say this is your array, and if it has been rotated by 2 points or 2 indexes, how it will look like? So it would be something like this. So we have shifted the elements by 2. Let's say if we shift by the elements by 1, how it would be 1, 3, 7 and 13. All have moved 1 point and 20 will come in the starting. Now if we move it further, so everything will move forward further and 13 will come in the forward now. So you can see that this was originally a sorted array, but now it has been rotated. Even if it has been rotated, you can see some part of it is still sorted. This is still sorted. 137 is a sorted sub-array and 13 and 20 is another sorted sub-array. So our first approach lies on this observation only, where we want to find the pivot point. The pivot point is the point to which the left of the sub-array is sorted and the array to that right of that pivot point is also sorted. So in this case, the pivot index here would be 2. It is 0, 1, 2, 3 and 4. So now let's understand the algorithm first, like how we will be finding that pivot index. So in the first approach, we first need to find the pivot index, and then we divide the array into 2 sub-arrays and perform a binary search on each of these sub-arrays. Okay. So we will be starting it with let me start it with the function find element. What we are going to, or let's name it as the find pivot element, not even the element. Because right now we are not finding the element, we are finding the pivot element. That is the first part. So I would be saying find pivot. The input to this would be array, a low index and a high index. When you start with this function, the low index would be the 0th index and high index would be the nth index. We should always have a condition. If low is greater than high, then return. For any recursive function, it is very necessary to define a base condition. In this find pivot method, I am not passing the element or the key that needs to be found, because we are just finding the pivot element. Once we find the pivot element, then we can pass that key or the element to the binary search function. Okay. Now what we need to do is we first initialize the mid value. As usual, it would be low plus high divided by 2. Now we are going to do is if a of or the array of mid minus 1 is greater than the array of mid, it means that that is the pivot point. So if we do a quick observation on the original array, we see that when mid was the index 2, we see that the value at mid minus 1 is greater than the value at mid. It means that the index at which the element 1 is present, that is the pivot. So this is a general observation that whenever the array has been rotated, if mid minus 1 is greater than the value is greater than a of mid, it means that the rotation has happened at that point. Similarly, if you observe that if a of mid plus 1 is less than a of mid, it means that the array has to, here we have shifted the array towards the right. If the array has been shifted towards the left, in that case this condition would hold true and we would get to know the point at which the array has been rotated. And let's say even this was not the case, then now we need to figure out in which sub-array the rotation has happened. So it would be like if the value at low is greater than the value at mid, it means that the rotation has happened on the left sub-array. Because if an array is sorted, in that case, the value at low would always be less than the value at mid. But if this condition holds true, it means that the rotation has happened. So we will be calling this function find pivot with the array, and low and the value of high would be mid minus 1. And let's say even if this is not the case, it means that the rotation has happened on the right part of the array. So we will call this function with the low value as mid plus 1. I'll just rename this array as well to A only, because we are taking the reference as A everywhere. Okay. So now once you have the pivot element, then the next we have to do is we will be dividing this entire array into two sub-arrays and recursively calling binary search on each. So divide the array into two sub-arrays and call binary search on each of those sub-arrays. So the sub-arrays that we will be forming here would be from 0 to pivot minus 1. That would be one sub-array, and the other sub-array would be pivot to high. The complexity of this approach is big O log n, as we are doing binary search. Now let's see another approach to solve the same problem. Here, instead of finding the pivot element, we will be performing a modified binary search. So in each recursion, we will try to figure out which subarray is sorted from left to mid or from mid to right. Based on that, we decide the next search region. So I'll call this as the modified binary search only. So this would be like modified binary search, and here the inputs to this method would be your array, then the low index, then the high index, and the element itself that you want to find out. Okay, so first we will figure out the mid element. As usual, the mid element would be low plus high by 2. So before performing further, we will check if this element is by any chance equals to the mid element. We will be returning the mid index. If not, then let's see what we are going to do. Now we have to find out which subarray is sorted. So we will first check for the left subarray. How we will know if the left subarray is sorted? If the value at low is less than the value at the mid, it means that the array is sorted in the increasing order. So we will first check that, else if array of low is less than equals to the array of mid. Okay, let's say this was the case. Then what we are going to do is, now we have to ensure the element that we want to find, it must exist in that subarray, in that left subarray now. So how we will find out? We need to figure out whether that element exists in that. It means that we are going to do is if the element is greater than equals to the value at low index, and the element should also be less than equals to the value at the mid index. It means that that element lies in that subarray's range from low to mid. Okay, if this is the case, then we are going to recursively call this modified binary search with the array A, low index as low, and high index would now be mid minus 1. And the element that of course needs to be passed. Okay. Else, what we are going to do is, if this is not the case, else we are going to call the modified binary search on the right hand side. Okay, so it would be A comma mid plus 1 comma high and the element. Okay, so this closes the upper else if loop as well. Now let's say if the left array is not sorted, then what? Then it means that the right subarray is sorted. So in that case, we are going to do is, if again, before that we will need to check whether that element even exists in that particular range or not. So we are going to say is that if element is greater than equals to the middle element and element needs to be less than equals to the higher element. If yes, then we are going to call find element, oops, sorry, it is the modified search. Okay, so then we are going to call is this modified binary search on the right hand side. So array, then it would be mid plus 1, then high and the element. Now let's say this was not the case. Then what we have to do is we have to again find in the left subarray. It means that even though the right subarray was sorted, but then the element does not lie in that range. So there is no point looking in that. So we will be again finding the element in the left subarray. So the complexity for this algorithm would also be log n only, since we are doing what? We are just again doing the binary search only. Let's see this with an example. I'll explain this algorithm with an example. So let's take our previous example only. So the original array was 1, 3, 7, 13 and 20, and we rotated it with 2 positions. So the array become something like this. Now with this algorithm, these would be the indexes. So your low would be 0, high would be 4, and likewise mid would be 2. So this is your middle element. And let's say the element that we need to find out is 20. Or what say? Okay, let it be 20 only. It will probably cover most of the cases. Okay. So array of middle, is that equals to the element? No. Then we check if array of low is less than the middle element. That is also not the case. It means that the right hand side of the array is sorted. Now we figure out which array subarray is sorted. Now we need to check whether the element that we are interested exists in that range or not. So does 20 exist in that range? No. So it does not, 20 does not exist in that range. But how do we check that? If element, so 20 is greater than equals to 1, yes. Is 20 less than equals to 7? No. So we will be again doing is, we will again be searching in the left subarray only. Okay, so now you will be saying is low equals to 0, high equals to 1, so mid would be now 0. Okay, so this is your mid. Is mid equals to the element? No, it is not. Okay, so now next what we are going to do is we are going to check which subarray is sorted. So we check if array of low is less than equals to the array of mid. Yes, that is true. So it means that the left subarray is sorted. Again, we find out whether that element exists in that range or not. So we say is 20 greater than equals to array of low, which is 13, and at the same time is 20 less than equals to 13? No. So we are going to again find in the right subarray. In that case, now low would be 1, high would be 1, and this time mid will also be equals to 1. So now when mid is also equals to 1, we will the first condition becomes true this time, that is array of mid is also equals to the element. So we return it as 20. And let's say we have exhausted all the iterations, all the recursions, and we are not able to find it, means that the element does not exist. And for that, for any recursion, always keep in mind that there has to be a base condition. And in this case, though we have missed it here, it has to be let if low is less than high, or let's say if low is greater than high, then just return. Always keep in mind to have a base condition for any recursion, otherwise it will go on into the infinite recursions. Thank you for listening to me. Please comment if you have any doubts.